Okay, so this question is quite fun. So three cells have an EMF of 1.5, all of them, and an internal resistance of zero point 0.6 ohms. And then which combination of these gives where we want an EMF, a total EMF of 1.5 volts and a current of 7.5 amps. So firstly, we can start to get rid of some of these things, some of these options. So each one's got 1.5 volts EMF, and we want a total EMF of 1.5. Well, because these are all in series, the total EMF there is going to be 1.5 plus 1.5 plus 1.5, so that would be 4.5. So it's definitely not that one. This one, you got one kind of the wrong way around. That kind of almost cancels out the other one. So you got, and you can think of it as a negative. So this is going to be 1.5 minus 1.5 plus 1.5. So this has got an EMF of 1.5 volts. So it could be that one. This one here, we've got 1.5 EMF volts here. Now these are in parallel, so they are 1.5 together, bizarrely, when they're like that. So it's going to be 1.5 plus 1.53, so it's definitely not that one. And then finally, these are all in parallel, so the total EMF is just the same EMF as each of those, so that could be 1.5. So it's one of these. So then we need to think about what else it is, a maximum current of 7.5 amps. So we've got a potential difference here of 1.5. And from V equals IR, so rearranging, the current is going to be the potential difference divided by resistance. So here the resistance is, they're just resistors adding up in series, so it's 0.6 plus 0.6 plus 0.6, so it's going to be 1.8 ohms in total. So we've got 1.5 divided by 1.8 ohms, and I could put it in the calculator, but I can definitely tell you that's not 7.5, so it's definitely not that one. It must be this one. Let's just check. So we've got a potential difference of 1.5. So we kind of calculated before, and then we've got each of these has got 0.6 amps. Excuse me, 0.6 ohms of resistance, and they're all in parallel. So when you have these in parallel, now we could put this into the resistance equation. You know, the 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3. But actually, when you've got them all the same, if you've got 2 in parallel, then it's halved. If you've got 3, then it goes down by a factor of 3, 4 by a factor of 4, etc. So actually the total resistance here is just 0.2. It goes down. So here, if we work out the current is going to be V over R. It's going to be 1.5 over 0.2. And if I put that into a calculator, it should come out as 7.5. I hope otherwise we've gone wrong. And yes, it does, 7.5. So the correct answer is